All right, last time that we met, we talked about the power rule for when we were multiplying. Basically, if we have two powers being multiplied together, we add their exponents together. Today, we're going to do something kind of similar. We're going to look at the division rule, and we're going to try to do it the same way we did the last time, where we're going to look at kind of a couple patterns and try to see if we can come up with the rule that's going on here to kind of shortcut it for us. So again, right here, I see I have 3 to the 6th over 3 to the 4th. I'm going to go ahead and rewrite this out. So the top, 3 to the 6th, that means I have 3 3s. 3 times 3 times 3 times 3 times 3 times 3. Okay, that's 3 to the 6th. I write out 6 3s. All right, cool. In the denominator, I have 3 to the 4th. So let's go ahead and let's write out 4 3s. 3 times 3 times 3 times 3. Zoom in here a little bit so we can see a little bit better. Okay, so I have all these 3's here I wrote out for 3 to the 6th over 3 to the 4th. Now, I know that if I divide something by itself, it equals 1. And basically, it makes that big, giant 1 that we can cancel out. So like here, oh yeah, I've got a 3 in the top and the bottom. Those are going to go away and become 1. I don't have to worry about them anymore. Let's see how many pairs of these I can make. Well, I see another one right here. There's another pair of 3s, so we'll cancel those out. I see another one right here. I'll go ahead and cancel those out. And then I see another one right here. I will go ahead and cancel those out. So I've canceled out 1, 2, 3, 4 pairs of these 3s, and I'm left over with 2 in the numerator. Well, I can just do 3 times 3, because that's what's in the numerator. Okay, so we have 3 times 3. And I could write this out as 9, because that's what it equals. But just for the sake of coming up with this rule, let's go ahead and let's rewrite it as a power. 3 times 3, well, I'm multiplying 3 by itself twice here. So it's going to be 3 to the 2nd power. Do you see a connection of how we could get from this to this? Well, let's do another one. Let's look at this one right here. We have m to the 8th over m to the 5th. I'm going to go ahead and write out what's called expansion where you write these out. So let's go ahead and write them all out. M to the 8th, that's going to be 8 m's multiplied. So I got to write a whole bunch of m's. All right, m, and then one more. All right, we got 8. All right, cool. And then the denominator, I'm going to go ahead and write 5 m's. M times m times m times m times m. Oh, I can really see it's a pain in the butt. I kind of hope we can come up with a shortcut so I don't have to do all this. Again, I'm going to look here and see if I have any of these pairs that I can cancel out. Well, I see a pair right here. We can go ahead and cancel those out. I see a pair right here. We can go ahead and cancel those out. I'm just going to keep making these pairs and canceling them out. And as I do that, I'm going to then go ahead and take a look at what's left over. And interestingly enough, I see I have 1, 2, 3 m's left over in the numerator. So I'm going to rewrite that as m times m times m. And again, I can rewrite this as a power as well. I know that this is really m to the 3rd. Do you see how we went from this, m to the 8th divided by m to the 5th, to this, m to the 3rd? Can you think of a shortcut to get from here to here? Keep that in your brain for a second. Let's look at another example, a little bit weirder one. A to the 3rd, b to the 4th over a, b to the 5th. Well, again, I can use expansion to try to help me out and see these pairs that I have. In the numerator, I'm going to have 3 a's. Kind of big a's. I'm going to have 3 a's, and I'm going to have 4 b's. Okay, 3 a's and 4 b's. In the denominator, I'm going to have 1a. So in the denominator, I'm going to have 1a. But then I'm going to have 5 b's. 1, 2, 3, 4, 5. Okay, well, let's go ahead and let's start canceling a couple of these out, see if we have any of these pairs we did up here. I see 1 pair of a's I can cancel out, but that's it. I can see a couple pairs of b's. I got this one, go away. I got this one, go away. I've got this one, go away. I got this one, go away. And it looks like I'm left with a b in my denominator. So I have two a's in my numerator, a b in my denominator. So let's rewrite that. Let's write that as a times a over b. And again, I can rewrite this using powers. This is really a squared over b. Now, we haven't quite talked about this rule yet, but I actually can rewrite this again, because whenever I have a variable in my denominator, that actually just means it's to a negative exponent. So in all reality, this is actually a squared, and then if you remember, this b secretly has a 1 hiding here if I don't see it. So it's actually b to the negative first. Do you see how I can get to this from this over here? All right, hold on to your thoughts. Let's look at one last one. Here we have some coefficients. We have these numbers out front. Okay. In order to do this, we're going to have to take out a number that goes into both 15 and 25 and then cancel out that pair that it makes. Hopefully you can see that 15 and 25 both have 5 that comes out of them. So I'm going to take out a 5, and I'm left over with a 3. So 5 times 3 gives me 15. And then in the denominator for this 25, I'm going to have 5 times 5, because that gives me 25. So I just looked for a number, right? What's the number that goes into 15 and into 25? 5 was the number, so I wrote it out, and I wrote what was left over here. Then I have w to the 4th, so I'm going to have 4 w's. So let's go ahead and let's write 4 w's. I'm going to have to make my fraction bar a little bit bigger, I think. That's a w. Huh. Okay, let's make this a little bit bigger. And then I'm going to have 2 x's. So we'll go ahead and write our 2 x's. Again, you can see how time-consuming this could be if we don't come up with a rule. So we're really going to want to come up with a shortcut here to make this a little bit faster. W squared is going to be 2 w's in the denominator, and then x squared is going to be 2 x's. Well, if I go ahead and take a look, these 5's right here, they're going to cancel out and go away. That's a pair. I got a pair of w's right here. Cancel out and go away. I have a pair of w's right here. Cancel out and go away. And then for x's, I got a pair of x's right here. Those are going to cancel out and go away. And then I have a pair of x's right here. And once again, those will cancel and go away. So I'm going to be left with, if I look at what's left over, a 3 in the numerator, 2 w's in the numerator, and then a 5 in the denominator. And if I want to rewrite this as a power, which I'm going to have to write a little bit down here, it's going to be 3/5 w to the second. Do you see how we made a jump from this to this? Well, maybe some of you by now have kind of figured out the pattern here, especially if you think back to last time we met and we talked about the multiplication rule, because when we multiply exponents or powers together, we add their exponents. So it kind of makes sense that when we divide powers with the same base, we are going to subtract their exponents. Okay, so whenever we are dividing numbers that have the same base, we are going to subtract their exponents. Okay, make sure you fill that in. Okay, so we're subtracting their exponents. That's an n, and that's p. Okay, subtracting their exponents. So if I have 2 to the 5th over 2 to the 2nd, I look at their exponents, 5 and 2. I subtract those, 5 minus 2, and I can rewrite this as 2 to the 3rd. Same thing over here. If I have a to the m over a to the n, it's going to be a to the m minus n. You subtract their exponents. Here's what I'd like you to do. Look at these examples we did up here. Try to not write this expansion out. Try to use that rule we just talked about, the fact that you're going to subtract their exponents to kind of shortcut this. You don't have to do all this work. I want you to look at these 4 problems that are on your sheet. I want you to give them each a try. Remember the ones with the numbers out front. You have to think of a number that goes into both the top and the bottom number and then make those cancel out. So go ahead and try that for me. We'll meet back together and we'll talk about what you got. All right, hopefully you paused and you gave these a try. Again, you want to be trying to use that new exponent law we just talked about. Whenever you see division, you are really subtracting the exponents. So like over here, I see a to the 10th over a to the 4th. 10 minus 4 gives me 6, so it's a to the 6th. B to the 6th over b to the 3rd, b to the 3rd, because 6 minus 3 is 3. Over here, 32, I know it's 4 times 8, and that makes the 4's cancel out. So I have 8x to the third, y. And I wrote to the first. You don't really need to write to the first. Remember, if you don't write it there, it's still hiding there. But 2 minus 1, I can fill in a 1 here, so I remember that, is going to give me 1. So it's 8x to the third, y. Down here, I know that 42 is 7 times 6, so I went ahead and canceled out my 7's. So I got m to the 7th. 13 minus 6 gives me 7. N over 6. N had no thing like it in the denominator, so it just stays where it is. Now over here, if you went ahead and did this one, you may have ended up with this if you use our exponent where you're subtracting them. 3k to the third, e to the negative 10th, r to the negative 1st. You might have had a different order, but the order is not a big deal. Here's the thing, is that these negative exponents, and we haven't really talked about this rule yet, so you'll see this rule in the next video or two. But whenever we have a negative exponent, it's the same thing as writing that exponent in the denominator. So I went ahead and I just rewrote in the denominator to show you what your final answer is going to eventually look like. As of right now, we are okay with either one of these, but in the future, you're going to have to rewrite it so that these are in the denominator. So if you want to get the head start and start doing that now, you go right on ahead. All right, so that's kind of our lesson for today. Let's just do a quick recap of what we've talked about. We went ahead and we used expansion to try to figure out what our exponent law was for division. And what we realized is that whenever we are dividing powers, we are going to subtract the exponents. So 5 over 2, subtract those, I got 3. A to the m over a to the n, I subtract these, m minus n. And then we went ahead and we did some practice problems using the subtraction involved when we divide exponents. All right, guys, make sure you continue on and answer the questions, and thank you very much for watching.